What do all these have in common?
X is always the exponent.
X is the exponent. Good. Perfect.
X.
Okay, now this is the reason why we are studying logs, because when X is the exponent, we need a way to find the answer, and logarithms are what helps us. Okay? We have to undo the exponent, and logarithms undo exponents, just like addition undoes subtraction or multiplication undoes division. Okay.
So
These kind of problems where you have X as the exponent is really why we need logs. Okay? For example, if we're doing some kind of financial, you're investing some money and you want to know how many years will it take you to make a certain amount of money, that's going to be where the years is this little exponent up here. Okay? So that helps, logarithms will help us figure that out. Okay, to solve these equations for X, we're going to try to solve them. We rewrite them in log form. So how do you rewrite 2 to the X equals 20? Log base
2
of
20
equals.
X.
Good. Okay, can we solve that one on the calculator?
yes.
How?
2 to the
Wait, we can't set bases, can we?
You can't, can we? What base can we do on the calculator?
10.
10, that's it. Okay, how about B? How would you rewrite B?
Log 10.
We can do this one.
The one
Okay.
base of 10 to 48.
Log base 10 of 48 equals X. Good, we can do that one, can't we? That's just a log of 48, okay? How about C? How would you rewrite that one?
Log 10.8
Of
of 4. Wait, yeah, 4
equals,
X.
okay, that one we can't do on the calculator. How about D?
log 2.718 60 equals X.
Of 60 equals X. Now this 2.718 is not a random decimal. It is what we call E. And E is right above the division sign on your calculator. So if you do second division, it gives you a little E and push enter, 2.718281.
So could you? No, you couldn't do that one. Well, you could if you.
Well, yeah, but it's a base, so we can't.
Right.
But if we knew how, if we could do it with
Like on
different
their
bases,
calculator.
like on theirs, yes. Okay, and this E has to do with compounding interest continuously. You know how we compounded it daily and monthly and all that? But we never did it continuously. You have to use that number right there to do it continuously, and we may do some of that. Okay, which of these 4 equations could be solved using a calculator?
B.
Okay, let's solve it. Log of 48. Somebody did it a while ago.
1.68.
1.68. So you just do log on your calculator and a 48. Get 1.68. The common logarithm function on a calculator can evaluate logarithms in base what?
10.
It cannot evaluate logs for bases such as 2 or 0.8. And we're choosing those two because they're in these problems, and we're going to actually find a way to solve these. Okay? All right, we've got 2 to the X equals 20. There are no logs in there anywhere in there, but what we're going to do is take the log of both sides, because the log is going to undo something for us. And this is where the fairy log mother comes in, and she gives you 2 logs. So if you put an exponential equation underneath your pillow, then she will bring you 2 logs, one to put on either side of here. Okay, so we're going to have log of 2 to the X equals log of 20. Or just inserting a log in front of each side. Now, how does this help us?
You can do it on the calculator.
You have no
Well,
base.
you can do this on the calculator, but we still have an X here. We could put it in Y equals, find the intersection. It's one way to do it. This is one of the properties right here.
Oh, X log 2.
Okay, this one, right? Log of m to the n. Okay, so how can we change that? Log of 2 to the x.
Log
Right. Move this x to the front.
Yes.
Okay, so x times log of 2 equals log of 20. Okay, so now we don't have x as the exponent anymore. And we can solve for x. Exponents inside logs, like 2 to the x, can change to what? What's this side here? What's on the outside? What is this x doing to the log? Multiplying, so it's multiplication. It was the exponent, now it's multiplying the log. Okay, so we want to get x by itself, so we have to get rid of log of 2. And since they're multiplying, how do you undo multiplication? So we'll divide by both sides by the log of 2. So I'm going to write x log 2 equals log 20 again. And then divide each side by log of 2. And the log 2's cancel.
X equals log 10.
And we can't do that.
We can't.
No,
10.
it's not the same thing. Let's see. Let's do log of 10
Tens. 1.
is 1. And then let's do log of 20 divided by log of 2. See if they're the same.
No.
And they're not. Okay, so you have to do log of 20 divided by log of 2. You can't do 20 divided by 2. That is not the same as this one here. Okay? That is saying the log of 20, or the log of m divided by the log of n. That doesn't equal this. Okay?
Okay.
Everybody all right with that? All right. Okay, now we have an answer. Write down several decimal places. How about 4.32192? We'll go with that. Then we're going to check it and see if it actually works. So we're going to start with the original problem, 2 to the x equals 20, but in place of x, we're going to put 2 to the 4.32192 and see if it equals 20. Now, if you still have this on your calculator, log base 20 divided by log base 2, and that answer, you remember how to do that, where you can do 2 to the second negative. And does it equal 20? Yes.
998.
Okay, same thing, right. Because it's not, because we had, if you did the rounded decimal, then you're not going to get exactly 20.
Come on,
You'll
TJ.
get close. All right, so that works. Let's do the same thing with 0.8, see if it works. So, 3 log method is going to give us 2 logs, one to put on each side. Log of 0.8 to the x equals log of 4. And then what happens to the x?
You move it to the front.
So x log of 0.8 equals log of 4. Then divide by log of 0.8 to get x by itself. Another big long decimal.
It's not as hard as I thought it would be.
Negative, did you get a negative answer?
Negative 6.212567439.
And then check it. Let's see if 0.8,
I got 4. It worked.
I got 4, you got 3.99999. Okay. You use the rounded. Okay. Now this is going to really help us with a lot of things. But first we have one more property that we need to discover. Okay.
Yeah.
We're going to use this method to see that there's a shortcut, that we don't have to go through all
There
these
always
steps.
is.
Okay? All right, so in this, and on 5, 6, 7, and 8, we're going to do the same thing on all of them. First, in box A, we're going to rewrite this with a log function. So how would you rewrite this with log?
Log 6 over
Log, okay, good. Log base 6 of 104 equals what?
X.
X. Okay, all we're doing is rewriting it with a log. How about, let's go ahead and rewrite 6 for now. Log base what?
Log base
Start with your base, 1.5 of
22.
equals,
X.
okay. Okay, now they want you to use the method that we just did, where we insert a log on both sides of the equation. So we have log of 6 to the x equals log of 104. Then what happens to the x?
It moves to the front.
So x times the log of 6 equals log of 104. Then what do you do to get x by itself?
Divide
Divide by what?
by log 6.
So we're going to have the log of 104 right here divided by the log of 6.
2.592.
You want 5, that's 2.592 is good. Let's do 3 decimal places.
So do you want us to go to mode and switch it to that? Flip 3.
No, you don't have to. You can just round it. Or if you want to, you can. Just remember to switch it back later. Okay. Okay, so then do the same thing on number 6. Log of 1.5 to the x equals log of 22, and then move your x in front. And keep going, do 6, 7, and 8. Same way.
This number 7.2623. Sound about right?
Yeah.
Yeah.
Yep, should be right.
Wait, does it just want us to, on the last one, does it just want us to write it out ourselves?
Yeah.
Yes. They're gradually letting you do it yourself.
Okay.
Okay, those two are finished. They want you to compare the two boxes in each problem. So like what's inside this box compared to what's inside this box. And then the same thing over here, what's inside this box to what's over here. Same thing down here, and see if you see a pattern.
Oh, that's cool.
And then see if you can figure out what this is. If you see the pattern.
Yeah.
You got it.
Well, it's gonna be opposite.
Yeah.
So the.
I'll say it. Right. Oh, you're writing down. You can just write down there.
I think I got it.
Okay. See if you can put. Okay. What I've been looking at is compare this to this, and that to that, to that, to that, to that, and then see if you can. Okay, so if you compare this and this.
That's right. Log n divided by log b.
Oh, wait, I did my backwards. Hold on. That was my first one. What was it,
Were you squinting? Just
Yeah,
like-
0.644.
Oh, don't.
Sean got 0.643.
Okay, so.
I got 0.644. Got put it to the thing. So rounded for me.
Oh, yeah. Yeah, go ahead.
They got 1
Just
point
don't
something.
drink it.
The 1 point,
Oh,
that's what I had very track.
They did it backwards.
Okay. Yeah, that's right.
Then you'll be able to
You
swallow.
did
Well,
one.
first it was right, I never thought that was wrong, so I did it backwards. So it was
It'd be fine.
Oh, stuff. Kind of funny stuff.
Well, it's Thursday.
Kind of.
Back column struck.
No.
That's what happened.
Okay.
So, what's the shortcut here?
It's log the N over log of B.
Log of n
N
divided by log of b. Okay, yes, I was just making a weird G there. Okay, so this is gonna help us tremendously because now we can take problems that we couldn't put in the calculator before and put them in the calculator. For example, like number 9, log base 8 of 32. How would you rewrite that using this property?
A log 32 divided by log 8.
And then you can put that in the calculator and find the answer. Okay. Log 32 divided by log 8. So 1 2/3, or we can put 1.667, that's fine. Okay, so now this is awesome because not only will we be able to figure out these problems that have different bases now, we'll be able to graph them also. So go ahead and figure out 10, 11, and 12.
I'm loving this. Did you get a negative number?
Yes, I did.
2? You got a 2.
No.
How did you get 0.5 then? So,
Oh, you didn't get an O on it.
How did you get 2.25? Or number 11?
Okay, you're not closing your guns. And I don't know if that's making a difference or not, but.
It does.
Is that the
It
one?
makes a big difference. Oh, really?
2.2.
Yes, that's right.
I'm loving this.
Okay, did you get it now?
That's what you got.
Okay, what are you doing? You're not doing the right one.
7.
So it is going to this bottom.
I'm
Okay,
sort
what
of
was it here?
back, so one,
Base on.
Jeez. Okay.
So the base is on.
I get too beefy. I'll toss you around nowadays.
Okay, did y'all get them all?
All you do
Yes,
is
ma'am.
run.
Okay, what did you get for number 10?
Negative
Oh,
2.
that's
Negative 2. How about 11?
2.25.
How about 12?
Negative 2.5.
All right, now another thing I want you to write down right here. Base is on the bottom. Base on bottom. Okay, B and B.
Base on.
Base on bottom. And it's a little number, and it's kind of already close to the bottom. Another way to think about it. Okay, that one's lower. It goes on the bottom. Okay, so it's easy to get these mixed up. Forget which one to put on the top and which one to put on the bottom. Okay, so now we're going to use this to help us graph. All right, it's called the change of base property, and it's a really good property. Okay, we're going to rewrite each expression below using only common logarithms. So, what's a common logarithm again?
That's 10.
Log base 10. So, how could we rewrite this using logs?
Log 2 over log 3.
Okay, that was easy. How about 14?
Log x over log 4.
How about 15?
Log x plus 6 over log
Good. Log of x plus 6, and then the base goes on the bottom. So, log of 8 is on the bottom. And the
My
last
question
one.
like this, would we have to leave it blank, or would we have to like solve it, solve for A?
Dang it, Jed.
We can't. It's got x in it, so we can't solve it unless unless it's equal to something. Okay. So log of 1/2
Over log x
divided
plus
by
2.
log of x plus 2. Okay. All right. This is just leading us into graphing. So here, if we want to graph, okay. For example, consider the function f of x equals log base 2 of x. And they rewrote it as a log of x over the log of 2. And then they put it in y1. Log of x divided by log of 2. Okay, let's try 17. How would you rewrite this?
Log of x plus 4 divided by log 2.
Okay, log of x plus 4 divided by log of 2. We're going to put that in y1 and graph it. See, before we couldn't graph these because we couldn't do log base 2. But now that we have that change of base property,
Each Derek.
yep, it is.
That
Bless
means
you.
Derek's competitive and I won. That's all that matters.
Hunter, I respect you more now.
Okay, did y'all get this graph?
Yes.
Everybody okay with the graph?
Zoomed in
Okay.
on
I
that.
got that.
The new graph 18 and 19.
You're gonna beat me, Derek.
No, no.
You're right.
This one's upside down.
I got you.
A question on 19.
Yeah, 19's a little different, isn't it?
They'll move that to the exponent.
No, I would leave it. So we can just do 2
2 log. 2
Uh,
log. 2 log.
log,
Wait, no, 2 log x.
Log of
2
what?
log x minus 3.
No, because
No.
the minus 3 is not inside the x.
So would it just
Minus
be,
3 is the last thing you're going to do.
okay, so it would be 2 log x divided by 2 log 4 minus 3?
Yes.
Alright,
So it would look like this.
wait, so you can put 2 log x close parentheses minus 3?
No, because that minus 3 is not in there with the x. It's outside of it.
I'm surprised I
You're
got
not doing
that.
the log of
I guess.
3, are you? It says log base 4 of x, not like log base 4 of x minus 3. See what I'm saying? Okay, so you're going to have 2 log of x divided by log of
Just throwing it
4.
out there, I got that.
then minus 3, like that.
Inputted that wrong.
What'd you have, Derek?
I had 2 log of x minus 3 over 2 log of x.
Okay, yeah, you can't do that. Gotta do,
So does it kind of look like this? Damn,
I
there's
think
inequalities
so.
on the
I don't
bottom of
remember.
this picture.
I put it in.
It's almost flat.
True that.
Is it almost flat?
Yes. Did you get it in the fourth section? Fourth quadrant? Yes. Sector.
Like that?
Yeah.
Is that what yours look like?
Mine looks.
Yours is
down
different, isn't
Yeah,
it?
that's
Yeah.
what
a tad bit different.
Go back and see.
Oh, let me see.
I got 2 log x. That's in right.
Mm-hmm.
Oh, I did that wrong. I did something wrong.
Okay.
I found out what it did. I put the 2 in the both of them.
Okay. Justin, did you graph this one? Okay. You did? You put it in there? So it
So I'm
goes,
gonna want it. So the 2 has to go in the first one.
Yeah.
Again,
Yeah.
so say if that 2 becomes a 3.
uh-huh. Okay, and you probably could move it to the exponent and do it that way too. But that's a little hard. You're gonna have to do the log of x squared. We could do that. Let's see if it's the same thing. It should be log of x squared,
Squared divided by.
log of 4 minus 3.
fine.
And it's not the same.
No.
Did y'all get that?
That's cool looking.
It is cool looking.
Oh man.
Oh, I didn't divide. Thank
Oh.
This
goodness.
is what it looks like. It's still different
Woo!
though.
It's like,
It's just a line that barely goes out. Okay, that is not
What'd you get?
Like mirrored, almost looks the same. I'm about to head off you with this.
It's right here. The only part difference is this over here.
Mirrors.
It's the same thing. It's just mirrored over there. Okay, but I need to find out which one's correct. This one's correct though. I know this one's correct. That was the first one we did. Okay, let's use the change of base formula to solve inequalities now. So, put this one in Y1.
Hey Bob.
What
What time do we get out of here?
It's 27. You got 18.
Okay, so log base, what do we put here? Log what?
Log
log
base
x
plus
minus,
Log of x plus 5
Divided
divided
by
by,
one.
by
Three.
log 3.
and then
log of
y2 is 2.
and then y2 equals 2. And we'll sketch the graph. Does it look like this? Okay.
So that's really like way harder.
Pretty easy, isn't it? Okay, and then we need to find the intersection. So second trace, intersect. It is 4 right here, isn't it? I didn't quite draw the right spot, but. Okay, so it wants to know when is the log function less than 2? So what part would you shade? The part above or below? Below.
So it's just.
And there's something special about this because this has an asymptote somewhere. Okay?
5.
How do you know it's 5?
Because
Because I
it
counted
shifted
little
left.
dots.
Okay.
Shifted left.
And it shifted left 5, didn't it? Up here? Shifted left 5. That's another way we know. Also, you can go to your table and look at 5 and it should say error. And it does. Okay. So we're not doing just less than 4 because.
Negative 5 is less than x, which
Okay.
is less than 4.
Good. That's right, because it's between -5 and 4. Right here and here. And is there an equals? Do we need an
No.
equals? Why not?
Because there's not one in the problem.
Not one in the problem. Okay, do 21. And then we'll be done.
So I like to hear.
Of course, the bell's entering. But